Hi guys. All right. Today practice we are going to take a look at operational sequence of DOL, Direct Online Motor Starter. Now, our previous exercise we discussed about PLC. So that was what brought about this particular exercise. I wanted to put you through on PLC basic program writing. But before then, I want you to explore more about the connection method of a PLC. So first of all, I want you to familiarize yourself with the connection of this 3D component of DOL so that by the time we go into writing program using PLC, you know how to use your input and output devices rightly. So let me see if I can display, if I can have the PLC symbol here. I have one here. This is logo PLC, right? Okay. Logo PLC is used for a smaller scale automation activity. So we also have this one. We also have this one, 1200 series PLC. So we are going to make our PLC, write our PLC and terminate the connection of the input device and output device to the PLC. But we're going to start with logo PLC, this particular one. After that, I'll bring a 1200 series PLC. But the purpose of this particular exercise is for you to get yourself familiarized with this input and the output devices, how to make the wiring. Because when you're writing your PLC program, after that, you need to make your connections. You need to make your input devices and output devices connection to the PLC. So in that case, let's see if we can simulate this. First of all, you know the function before we start PLC programming. So let's simulate this, then you understand the logical function of this. I put on my MCB here. This is my start, stop button, emergency push button. These are my pilot lamp. So I put on this, monitor this area. This is the schematic. This one also represents the function of this termination process I just showed you in 3D. So this one come up to indicate that this contactor is in a closed state. Look at contactor showing red is closed. Then lamp is on. If I shut it down, here will go off and this other lamp will go off. This one is for the schematic, right? Okay, I think what I will do is put it on again. Take a look at this. Once here show red, you know that the contactor has closed, and that is when you see this lamp on, showing you the schematic representation and showing you this other 3D wiring method representation. Then if peradventure there is a fault within the mechanical impeller of this particular pump, this overload will trip. So let me trip it manually. You see the red lamp is up now, showing that there's a fault. This one's, oh, sorry, this one's supposed to be another red lamp as well. Let's change it to red. Let's change this to red. So I'm supposed to, I use red now. All right, so this one should be red to indicate fault error. Let's try again. Put it on here. This one is off. So let's trip. I trip it here. Yes, look at my red indicator telling you that there is a fault. So when there is a fault such as this, if you try starting the system again, it cannot start, right? Even if you put it off here, it cannot shut down. This particular lamp cannot shut down unless you come to the overload block device and reset it. Once you reset, the light will go off. But before then, once you reset, make sure that you rectify the fault before putting on the equipment the second time. Once you put it on and this one closed, look at the pump, look at the arrow showing you the direction of operation. All right, if that is taken. Now let's now go to the next exercise by bringing up our PLC. We are going to write program and make our connection. Let me put this PLC here. We're going to write a program using these input devices and make the connection into this PLC CPU. Then after that, They're bringing another PLC again, 1200 series. This is 1200 series. We're going to write another program linking the whole of the input and output into this particular PLC, right? Okay, that is the next exercise. Thank you.